you automatically think about maybe a certain triangle comes into your head, okay? And then we also have had conversation where somebody always thinks that when they secure right triangle that the other two angles in that triangle should be 45 and 45. Well, that's not always the case, right? I can have any two, well, not any, but I can have a lot of other combinations of those other two angles to make it up, right? They just have to add up to 90 degrees. So today we're going to look at two forms of what they call special right triangles. And why they're special is because their angles are always a set of angles that you can kind of do special things to. Okay, so we have two different versions of this. If I can draw this and try to make it perfect, I'm going to have this right angle right here. And realistically, it doesn't really matter what we call this triangle. If I would look at this triangle right here and assume that obviously these two legs make up my 90-degree angle, so they're going to be two of the sides, and then obviously we have our hypotenuse, right? That's going to happen in every single right triangle that we have. If you looked at this, and I have no idea if it looks that way, does it look like these two legs are the same length?
Yes.
Okay, hopefully they do. If they were the same length, then what would have to be true about the angles in that? They would be the same degree, right? So if we had the same length and they had to be the same degree, is there any possibility of multiple angles in this kind of problem? What's that? Multiple sets of angles. So if this side was the same length as this side, and you just told me that the angles opposite of them have to be the same, is there multiple sets of angles that would work in there? No, right? They have to be what? 2 45s, right? So I'd have to have 45 degrees here, and I'd have to have 45 degrees here, right? Yeah? Everybody agree with that? Yes. So what's the easiest way to make a comparison of two things that are exactly the same? We would say that they're what to what to each other? They were equal, you're right, but they would be what? Similar. What would their like scale factors? 1 to 1, right? So if I told you that this side right over here had a ratio of 1, then automatically we'd have to have another 1 down here, right? Because they're the same things. They're the same length. I don't care what the lengths are, I just know that they're the same. Because they told me that the angles were the same, the sides opposite of them have to be the same too. That makes sense? So if we went through then and I asked you to do the Pythagorean theorem to this, what would you get? If I took the, we're not saying these are the lengths, we're saying they're the ratio of the sides, but we can still do Pythagorean theorem with the ratios. So if I did 1 squared plus 1 squared, what would I get for c squared?
1.
Really? 1 squared is what? 1 plus 1 is equal to c squared. So 1 plus 1 is 2. And so how do I make c squared not c squared? I take the square root. So c is actually what? It's the square root of 2. So when we talk about special right triangles, this is our first special right triangle. Number 1 is a 45, 45, and then obviously we have a 90-degree right triangle. Okay? Now, what we just proved are the ratios of the sides. And this is important. The ratio of the sides, then if we do it in the same order, would be 1, 1, and the square root of 2. So every single time that you have a 45, 45, 90-degree right triangle, the ratio of the sides is 1, 1 square root of 2. It doesn't matter what the other lengths are, the ratio of the sides are always going to be the same thing. Does that make sense? So what I'm saying here is, if I told you that this was 4, and I called this, if we just go back and call this ABC. And again, why did we say this should be C? Because it's opposite of my hypotenuse, remember? Okay, so again, capital letters, lowercase letters is for the sides, but this is capital C. So if I told you that BC was 4, what else would you automatically know? AC has to be 4 also. Everybody agree with that? Because they're the exact same thing. The ratios are 1 to 1. So if this side was 16, then this side has to be 16. Everybody agree?
The hypotenuse is always going to be square root of 2.
So now the ratio of the side is square root of 2. So what's that mean? Well, that means this. If I have one of my sides or one of the legs, I have the other leg automatically. And then they're going to ask you, well, what is this side over here? And I'm going to call it little c. What is little c? Well, the difference between the sides are these ratios. These were 1 to 1, so they have to be the exact same thing. This side over here is square root of 2 compared to 1. Is square root of 2 bigger or smaller than 1? It's bigger, right? So if this is bigger, should this length be bigger or smaller than the 2 legs? We always know that it should be bigger in the first place because it's the hypotenuse, but it's just showing you that square root of 2 is bigger than 1. So how do I make this side, which is our hypotenuse, square root of 2 times bigger than 4? What would I do to 4?
Square both sides.
Why?
To get rid of the square root on the 2.
But why do I want to get rid of the square root?
You just double it.
Make it easier.
Just make it easier. Let's make things easier. Okay?
Let's multiply by 2.
Multiply. Why are you only multiplying by 2?
Because multiply by 2 cancels out the square root.
It does? If you have a square root of something and you multiply by 2, the square root's gone?
Well, because it's the square root of 2, so then if you multiply by the number inside of it.
It's a good idea, but no. I gotta multiply by the actual square root of that number. So if I do the square root of 2 times the square root of 2, then I would cancel it out. But still no.
What are you trying to figure out?
So I'm trying to figure out, how do I figure out what this length of this side is? If I know that it has, this length of my hypotenuse has to be a square root of 2 times the size of the leg, what would I do to 4 to get to this hypotenuse?
Multiply by 4 by 2.
By 2?
Square root of 2. No, you have to multiply 4 by 2 because then you get both sides and you can square that.
Multiply 4 by the square root of 2.
Yeah, I'm going to multiply 4 by the square root of 2.
That's what it's supposed to be.
Everybody agree with that? Okay, so here's what you do. Anytime that you have a square root, and I like to do it this way, if I have one of these lengths of the sides, I'm going towards the square root of 2, I'm going to multiply. Now again, this is where it gets a little confusing. Now you got to go to the outside and take the length of the side times that square root of 2. So what's 4 times the square root of 2?
4 square root of 2.
Oh.
The answer is 4 square root of 2.
Oh, yeah.
So what we're getting at is this. If I have the length of any of my sides, to find the hypotenuse, all I'm going to do is take the length of that side times the square root of 2. That's it. It'll work every single time as long as you have a 45, 45, 90 degree right triangle. Okay? If you are going away from square root of 2, so if you're going in the opposite direction, so now I would be given the hypotenuse and they're asking me for the lengths of one of the side, I am going to divide by the square root of 2. So if you're going towards, you're going to multiply. If you're going to go away, you're going to divide.
So you just divide by the square root of 2.
By the square root of 2. So let's do another one. Automatically, again, first thing, you got to try to make, how can I assure everybody that this is a right or a 45-45 special or right triangle if they don't give me 45 and 45? I can put arcs, okay? So they can do this. Automatically, I know that's a special right triangle, right? Or I could, like Brandon just said, I could put slashes there. Now we can't argue it, right? Without them putting the numbers 45. So the first version is this. If they automatically now, every single time that they give me this, I know that I have ratios of 1, 1, and the square root of 2. It's not the length of the sides, it's the ratio of the sides. So we're thinking about those scale factors again. Okay, so when we do the ratios of the sides, then if I tell you that this is 7, The bottom also has to be 7, right? Because the sides are automatically the same length. And what's my hypotenuse?
7 square root of 2.
So, my answer is 7 square root of 2. Now, I could always do the Pythagorean theorem to this, right? Because it's a right triangle. And I have a squared and b squared. But basically, if I do a squared plus b squared, I'm still going to get the exact same thing. Because I get 49 plus 49, right? And then we would take the square root of 49. Or add those together and then take the square root. Which should come out as 7 square root of 2. But it just makes the process a little faster. That's all that it's trying to do. Okay?
Can you show like going away from it then?
Get in there. Yeah. Okay? So we go to this. It doesn't matter what those sides are, right? So if we have radicals on those sides, right? 45, 45, 90, right? Automatically. Even if it doesn't look like it. If they put those little slashes there, it's 45, 45, 90. Good? So let's say that this is 2 square root of 3. So what's the length of this side?
2 square root of 3.
2 square root of 3. And what's the length of my hypotenuse?
2 square root of 6.
Remember now, this is 1 square root of 2 all the time. So I'm going towards the square root of 2, so I'm going to take the length of the side times square root of 2. Insides by insides, outsides by outsides, right? So the square root of 2 times the square root of 3 makes this
2 square root of 6.
2 square root of 6. Can I reduce square root of 6? No. Don't turn it into a decimal. Okay? Look what it says. Leave answers in radical form. Don't turn in decimals. So when you ask, hey, can I turn it into a decimal? I'm going to throw a marker at you. Yes, you would. Okay? Makes sense if they give you the leg? Easy, right? So now, if we're going to be given the hypotenuse, same exact thing, right? They don't even have to show it to me. They just have to put those slashes on this. And they tell me that this is 10. So now they're asking you what is the length of these two sides. And we could call this x. And if that's x, then this has to be x, right? So how do I find x? Well, now, we still have 1 square root of 2. But we're going away from the square root of 2, so we're going to what?
Divide.
We're going to divide. So we're going to take 10 and divide it by 2. Now again, this goes back to our rule. I can never have a radical in the denominator, so I have to what? Rationalize my denominator.
Multiply by square root of 2.
So that means I multiply by whatever's in the denominator over itself.
So 10 square root of 2.
Okay? Again, remember when we're multiplying, these are fractions times fractions. Don't go through and try to reduce. If you reduce, we go right back to 10 over the square root of 2. That's what we kind of talked about the other day, right? So now we're going to multiply straight across the top and straight across the bottom, and now we get what?
10 square root of 2 over 2.
10 square root of 2 over 2. Can I take a 2 out of everything?
No, just the outside.
Just the outsides. Perfect. So when there's a same number, multiple of the same number in all three of them, I can only do the things that are both on the outside. So this answer turns into what?
5.
5.
2 over 1.
Square root of 2. And if you wanted to put it over 1, you could. Okay? So, we are going away. Whenever you go away, you divide. When you're going towards, you multiply. Okay? Let's try it again. So let's say now we have...
Is this a radical?
Say it one more time, what?
A radical and hypotenuse.
So now they're going to tell us this. Do I have to even put both 45s?
No.
No, once I put one 45, the other one has to be 45, right? Okay, so now we say this is, I don't know, 2 square root of 3. So again, automatically, anytime that I see this, I can automatically say 1, 2, or 1 square root of 2. And again, how did we get those ratios? We did the Pythagorean theorem. Okay, so now we're going away from the square root of 2, or towards one of the sides. So we're going to say 2 square root of 3 divided by what? The square root of 2. So again, when you do this kind of special right triangle, you only have kind of one option of numbers, either 1 or 2 or square root of 2. So now we're back to, well, it's not equals, but times. We're going to rationalize the denominator again. Oops, I forgot the 2. Okay. And again, don't look diagonal, because we're going to get back to where we were, and now we just do the problem. So on the top, we get what?
2 square root of 6.
Perfect. On the bottom?
2.
We get the square root of 4 or 2, right? So what's my answer?
2 equals
2 over 6.
just the square root of 6, right? My 2's cancel each other out. Okay?
So you don't apply that, simplifying to the inside of the radical, correct?
No. You got to think about the radical as being like a shell or a boundary, and it can't bust its way in there. Okay? First one, pretty easy, right? 1 square root of 2. Okay? So the second one then, big number 2, would be, try to draw this triangle as close as you can. Make one side way shorter than the other. Now, if you think about everything that we've talked about so far, right? The lengths of the sides kind of goes with the opposite angles, right? Meaning, if you have the length of one side and it's the shortest side, what should be true about the angle opposite of that? It should be the smallest angle, right? Everybody remember all that? So again, I'm going to call this C, and let's call this A up here and B down here. It doesn't really matter again, but just so we stay consistent. So, if this is true, obviously I got a 90-degree angle because I got the box. And where should my smallest angle be in that triangle? At A, right? At A, because it's, obviously we can tell, well, hopefully you can tell, that this is the shortest side. Okay? So, in this special right triangle, I'm going to tell you that this is 30. If that's 30, then angle B has to be what?
60.
60. Okay? Everybody okay with that? So, my second special right triangle, big number 2, is going to be a 30, 60, 90. So, we're going to kind of do the exact same thing with this. If this is true now, and we want to do it in the most simplest terms, like we did over here with the ratios of the sides, we said that these two sides were the exact same, so they were 1 to 1, right? So if we make the smallest side the easiest number we can work with, we would make the smallest side into 1. And what would be true about then AC, the length of that side?
2 times.
It's got to be 2 times the length of the first one, right? So the ratio of this would be 2. Okay, so then if we did the exact same thing that we did over here, we applied the special right triangle, or sorry, the Pythagorean theorem to those numbers, we'd have 1 squared plus 2 squared equals c squared. Would you agree with that?
Yeah.
Okay, so 1 squared is
1,
plus
4,
equals
c squared.
equals what?
C
Well, let's
squared.
say like 1 plus 4 is 5. We equals c squared.
Square root of 5.
So square root of 5 is your answer. Square root of 5.
Yeah, no, but that doesn't make sense. Because that's not what it is.
Square root of 7.
Oh, here's the problem. Here's the problem. Okay?
Forgot square root of 3.
So our numbers should be 1, 2, and the square root of 3, right? And it should be like this because we're thinking about the angles being doubled up. So the sides should actually be doubled up. But the lengths of the sides aren't necessarily the exact proportion as the lengths of your angles. All right? So if I told you that we had these possibilities of 1, 2, and the square root of 3, what would you say is the biggest number between those 3 things?
2.
Everybody good at that? Because the square root of 3 is really what? 1 point something, right? So if it's 1 point something, then 2 has to be the biggest side. So basically what we're saying here is then if 1 is the biggest, we would have 1 squared plus the second biggest has to be the other side. So I'm going to take the square root of 3 and square that. And then the last side would be 2, and we can square that. Does that prove that we have a right triangle? If I did that, what's 1 squared?
1.
What's the square root of 3 times the square root of 3?
4 equals 4.
Is that equal to 4?
Yes.
Yeah. So our ratios of our sides for this is 1, 2, square root of 3. But you always have to realize that the hypotenuse, which is the longest side, has to have the biggest ratio. And the biggest ratio in this case is 2. And so that means the square root of 3 has to go opposite of 60.
So everything would go towards the radical, or would it go towards? So that's for every
That's for 30, 60, 90 only.
Right. So if it's a 30, 60, 90 right triangle, we have this. If it's a 45, 45, 90, we have this. Okay? Now ask your question again.
Never mind, if I get to it, it's fine.
Okay? Alright, so, everybody okay with how we got the numbers? 1, 2, square root of 3. Now, so again, if we did the same thing over here, my ratios of my sides. I'm going to write 1, and then what goes with 60? Square root of 3, and 2. Now this is where a lot of people mess up, because a lot of times when people say, well, what are the ratios of the sides? They'll say 1, 2, square root of 3. But when they say that, then a lot of people think, well, if it's 1, 2, square root of 3, this should be 30, this should be 60, and then my 90-degree angle. And that's where they get messed up, because 2 is actually bigger than the square root of 3. Okay, so just slow down there. All right, so these are my ratios. So when the biggest thing that's confusing about the 1, 2, square root of 3 part is that you always have to move from the one side. Okay? So what I'm saying here is this. If they gave me the hypotenuse, I have to go back to the one side. If they give me the hypotenuse, I cannot go straight across and go to the leg with the square root of 3. I always have to move from the one side. So the easiest way for me to do this is if they actually give me, in this particular example, BC. Okay? But the same rules are going to apply. So when we say we are going towards and away, we're going towards and away from whatever they give us. So if I'm given this and I'm going towards 2, I'm going to what?
Multiply.
I'm going to multiply. So if I'm at 1 and I'm going either direction, I'm going towards 1, I'm going to multiply. If I have either one of these and I'm going back or away from the sides, and that's where it gets a little confusing, because then you can say, well, I'm going towards 1. But you're not. You're basing everything off of 1. So remember that. When I go from 1, I got to go to the other sides, and it has to get bigger, because 1's my smallest side. So anytime that I'm going bigger, I'm going to multiply. Anytime I'm going to get smaller, I'm going to divide. Okay? So away from 1 or towards 2 and towards the square root of 3, I'm going to multiply. If I'm going back to 1, I'm going to divide. So again, if they gave me this length right here, make it real easy, 4. If they gave me 4 and they asked me what's the length of my hypotenuse, I'm going towards 2, so what do I do with 4?
Multiply it by 2.
I'm going to multiply it by 2, so this side is what? 8. If I'm going from this 4 right here and I'm going towards square root of 3, what do I do with 4 and square root of 3?
4 square root of 3.
I multiply. And I get my answer. That's it.
And then dividing it.
Okay? So then, if we come back here, they give us another one. They tell me that this is, nope, this should be 60. How do I know this is 60? Because it's opposite of this side, right? This is 30. So if they tell me this, as soon as they tell me that it's a special right triangle, and Gabriel said this earlier, it has to and only works for 30, 60, 90 right triangles. These ratios. That's why it's special. Okay? So automatically, my ratios, what should be opposite of 30 down here? The ratio. 1. What is my hypotenuse? 2. And then I'd have the square root of 3. Now, the first one was real easy because they gave us to the 1 spot. Now let's put it over here. Let's say my hypotenuse is 20. Okay? So from 20, I'm going away from 2, or I'm going towards 1, but I'm going away from 2. So again, if I go from 2 to 1, I'm doing what? I'm dividing, I'm getting smaller. So what do I do to 20? I have to divide by 2, so this is what? 10. So I get 10. Now I'm at 1, but I'm going towards, and I'm getting bigger again, right? So now, when I go this way, I have to do what? Now I have to multiply, and I get 10 square root of 3.
But then,
But as soon as you get used to this, boom, 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 you're going to go through this really fast.
so then let's say they gave you 5 for the other side for square root of 3. go 5 divided by the square root of 3, and you're going towards 1. So the same.
Yep, we're getting there. Yep. Okay. Make sense though? So again, like I said, you can use this anytime from here on out when trigonometry is involved, as long as it's a 30, 60, 90. Or you can just go and do trigonometry, which is the next section. Okay? So that's all up to you. But any chance that I get, I would use these things because they're just easy. They're way faster than trigonometry. They really are. All right? You just got to get used to them. Okay? So then the last one would be if I have this, and again, for whatever reason, I always draw it that way. So let's draw it a different way. Let's draw this way. All right? So now, if I know this is 90, this angle right over here should be what? This should be 30. Everybody understand why that should be 30? Yeah. Because again, it's opposite of the shortest side. Okay? So now, we're actually looking, so now, right away, I would come in again, I would put my ratios. So opposite of 30 has to be 1. My hypotenuse has to be 2. And this has to be the square root of 3. Right? So now let's say that this is, what'd you say, 5? That's fine. So if we have 5 here, now I'm going away from the square root of 3. So when I'm going towards 1 or away from the square root of 3, I'm going to what? I'm going to divide. And so I'm going to take 5 divided by the square root of 3, and I get what? Times the square root of 3 over the square root of 3. So we get what? Perfect. Now, I'm at the 1 side, and I'm going towards 2. So this is 1 right here. If they give me this length, where it's the square root of 3 side, I cannot go from that straight across to the hypotenuse. I have to go through 1 and then go back. So what do I do with this if I'm going towards 2? I'm going to multiply this by 2. So times 2 gets me what?
10.
Perfect. And I get that. Okay? So it's basically a lot of repetition as long as you can remember the ratios and that it only works for those 2 situations. That's why they're special. So in the next or the next section, when they give you a right triangle, but they tell you that the 2 angles are 40, and then it would have to be what? 50, 40 and 50. I can't use these 2 things. I have to use trigonometry. But I can always use trigonometry. So I can do trigonometry to these 2, but I can't always do special right triangles to everything. That makes sense?
Well, this is easier than the trig.
It's faster.
Faster, sorry.
Okay? As long as you can remember all that stuff. So again, it's hard at the beginning, but this would be something that you could use to your advantage in ACTs or ISATS tests and that kind of stuff. Okay? So, what do you think? Not too bad? Alright, let's see what I missed. Look at all those notes that we went through that fast. So let's check it out. What time we got? Alright, here you go. So, again, don't think about this real quick, but in a sense, think about it real quick. So, do I have one of my special right triangles?
Yes.
Yes. What are my ratios? 1, 1, square root of 2. So what's x? 9 square root of 2. That's it. That's the answer. See how fast it is? So as long as you can take that and look at it and say, hey, that's the same thing as this. I know that it's 1, 1 square root of 2. I know that it's 1, 1 square root of 2. I'm just taking 9 and multiplying by the square root of 2. That's my answer. That's it.
It's x is square root of 2, right?
X is on the square root of 2 side, the ratio of that side. Yes. So my answer is 9 square root of 2, and that's it. That's my answer. See how easy it is once you get the hang of it? They did the same thing. So obviously here, exactly the same thing though, right? 1, 1 square root of 2, so what do I do with 8 square root of 2? Multiply by the square root of 2, so what's my answer?
8 square root of 4.
16, right? 8 square root of 4, square root of 4 is 2, 2 times 8 is 16. Agreed? So again, we want to simplify as much as we possibly can, so our answer would have been C. Make sense? See how easy it is once you get the hang of it? So now, when you divide, you might have to take a little bit more time, right? Because division sometimes bothers more people. But basically, all we're doing in this case right here is I'm taking 8 and doing what to 8?
Divide by the square root of 2.
I'm going to divide by the square root of 2. And again, when you're dealing with 45, 45, 90, my options are 1, 1, square root of 2. So I'm basically going to use the square root of 2. If I'm worried about 1, why am I worried about 1, right? If I multiply or divide by 1, it's still the same answer. You know what I'm saying? So, if I simplify, we get what?
4 square root of 2.
4 square root of 2. Make sense? Everybody okay with that? Okay. Again, this is where if you're having problems and everybody else is saying yes, you can say no. I got no problems explaining.
You get 4 square root of 2.
Then reduce.
Yeah, you actually get 8.
So I'm going to take this, right? Okay. And then my 2 2's pop out, and then you reduce the 8.
Because you get 8 square root of 2 over 2 square root of 2.
Okay with that?
So 8.
Everybody else okay? Again, if you got questions, please ask questions. Ooh, we got kind of looks nasty, right? These are when people kind of start freaking out. So again, especially at the beginning, the first thing I do in this case right here is write this in on my paper and not in my book. And opposite of 30, the side has to be what? 1. Down here has to be, because it's the what? And the square root of 3 has to come over here because that's all I really have left. Okay, so everybody think about this. Don't say it out loud. Again, this one's the easy one, right? Because we're starting with the one side. If you're starting with the one side, we're going to multiply both ways, right? Because we're going this way. Okay, so what's 4 square root of 3 over 3 times 2?
8 over 3 over 6.
8 square root of 3 over 3.
8 square root of 3 over 3. Don't multiply by the inside. You can only multiply by the outside, right? So we'd have this. 4 square root of 3 over 3. Ooh, that's a 3. Times 2.
Yeah. Oh, I just said it wrong.
Did you?
Yeah.
So we'd have what? 8 square root of 3 over 3. Everybody agree?
Oh, you can't multiply them.
Right. Don't take the something that's under the radical times something that's outside the radical.
No, I'm talking.
He's talking about this 3.
You can't multiply. They had to multiply 3 times 2 then.
But I multiplied straight across the top and straight across the
2
bottom.
is 2 over 1.
So I have 3 times 1 on
Oh,
the bottom.
that's it.
Okay? So now, if I take 4 square root of 3 over 3 times the square root of 3, what do I get?
Oh, it's complicated.
What's the square root of 3 times the square root of 3? So this should be what? 4. Square root of 3 times the square root of 3 gives me 3, and 3 over 3 cancel out. Everybody see what I'm saying there? You need to see it written out?
I thought you were
I
talking
did 4 times 3.
Not talking. Is it the same thing? No, right? So again, the first thing I'm going to take the time to do is this. 1, 2, and the square root of 3. So if I'm going back towards 1, what do I have to do? Multiply or divide? I'm going to divide. This one's easy, right? Because I'm going to take this divided by the square root of 3. So what's my answer?
4.
Holy cow, look what my answer is. And we're done. That's it. Those are the sides. So once you get the hang of it and you can understand if I'm multiplying or dividing, then you can really go bang, 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 bang. And I'm not trying to say that it's that easy, but it's that easy. Okay? You just got to get the hang of it. All right? And again, the most is like going from here to here You just have to remember that you gotta go back to 1. So anytime that I'm going back to 1, I'm going to divide. Anything I'm going away from 1, I'm gonna multiply. So you really gotta think about, am I getting bigger or am I getting smaller?
Will all the ratios be like 45, 45, 90, and like 30, 60, 90? Or is there any
Today?
difference? Yeah.
Yes,
Okay.
because
Today.
they're special, okay? And when we get to the trade ones, sometimes there'll be these two and you can go back to this, but then you can always do trigonometry. But today, yes, they're gonna be like this all the time. Everybody good? Okay? Did it stop again?
No.
So, here's our problems. Make sure you read the directions